Oh, creep. Also, what happens is on creep is more predominant on tubeless tires. Okay, but here our civil aviation guys are not that experienced, you see, so they tell you to put even creep marks on tube tires. But if you put it on a tube tire, what will happen is, if this is the tube, and you see this is the hole for your okay, this is I can remove that. So this is on the outside, yeah. So your tube goes through there and the valve comes out here. Okay, so now for example, if your valve is here, okay, your valve should be exactly in straight position when you this thing, because this will also move, yeah, because your tube is inside there. When you're putting it together, you can't have a valve sitting at an angle. You have to move it so that the valve comes through and it is free, you know, it's not at an angle. That means you haven't aligned it properly. So when it is not aligned properly, on the tube tire, as I said, we are talking about creep now. So which means on an observation, when you do a pre-flight and you find a tube, the valve sitting at an angle like that, that means what happens is, on impact, this thing, the tire can slide. Do you understand? Because of heavy, and with the weight and the forward movement actually moves, so the tire moves slightly, yeah, and the hub remains in place. You understand? So that is known as creep. So basically, you put two marks on the rim and you put it on the tire. So if this thing moves, then immediately you know that they're not aligned. Okay. So if it has moved, that means the tire has moved. Do you understand? And it's more prominent on tubeless tires, not on tube tires. On tube tires, we put it here because they ask us to put it, because otherwise it's a finding and they don't approve our COFAs, yeah, when they come for COFA renewals. But the valve will actually indicate, it's a first indicator which will tell you whether the tire tube has not moved. So what will happen is, if you see the creep marks are not aligning, you have to remove the deflated tire, align it, and see if there is no other damage on the inside, yeah. Yeah, heavy braking also. So basically what happens is that as soon as, sometimes if the runway is short, the guy lands, as soon as he lands, he applies brakes also, you see. So there's a lot of other factors which cause creep. But usually low tire pressures also cause creep, much creep. If it's not correctly inflated to the right pressure, can cause that. The maintenance of tires is tire pressure, inflation procedures, and examination of tire fittings. Fitted tire examinations. You will find different types of. What is the book now? So these are different types of tires. Yeah, you see the thread. This is the one I'm talking to you. They use this for landing on large riverbeds and all that. It depends what sort of operation you are in. Different operations require different types of tube, and they have different types of thread to compensate for that. You see, these are all different types. Yeah, you see here, this is a wheel half, yeah. The bead sitting area here is, the wheel flange is here. Usually, you know, on aircrafts, the damage, if it's damaged, the weak point on this is what? Is usually this area here, okay? This area is where you will have failures. Here is the most important, because you get small cracks occurring here, because if it's heavy landed too much, there is a lot of force going towards the outer end because of the weight of the aircraft. And the other one is, you will have where the bolts are attached, which means even if the one hub moves, or if anything is left loose, you will find little minor cracks occurring, originating from the tire here in these positions. Okay, here you will find little cracks visually when you check it visually. The other point is you see this has got little ring. In order to lighten, you see on aircrafts everything must be light. You can make this into a single piece, but it'll be too heavy. So what it does is it's design. It's a design factor to make it. You have these, lightening. They lighten the. You see, this is thin. This is thick here. This gives it the rigidity. This gives it the strength. These flutes here give it the strength to the hub. Okay. So the weakness is here, points, and around here. So when you do a hub inspection, that's the other one. The other inspection that you do is this is your wheel bearing here. It's a interference fit. Do you know what an interference fit is? Huh? Speak up. Then what is it?
Interference fit is well like the hole is made like bigger than the shaft.
So wherever you want to install it, it's bigger by how much? There is a journal. You should know generally. You can't put a 3-inch hole with a 3.5 inch. You understand what I'm trying to tell you? It's measured in thou. Usually minimum is about 2 to 3 thou. Okay. So basically that means this thing is made of magnesium alloy. Yeah, see, it's light. If it's aluminum, it would have been heavy. This is magnesium alloy. Okay. So